So it's different from a manned station. A manned station, there's someone in the office. Automatic station is automatic, there's no one there. But you still get the same parameters there. Your temperatures, your wind direction, your wind speed, your rainfall, all of those parameters we still get. The only difference is that at the manned station, there's human intervention there. Who will give you issues about clouds? Is it raining? The type of clouds, the height of that cloud, all of that detail. But with this one, the only thing that is not there is the visual observation. Okay? So now with this one you get almost 7 parameters. So this is what you call Stevenson screen. I'm not going to give a lecture. You remember we used to call it a Stevenson screen, but technology is taking over now. Inside the Stevenson screen, you remember Mr. Malala told you about this WMO thing. We get standards from WMO, ICAO, and all of those bodies. So even the orientation also, you remember. You don't just come the Stevenson screen and put it there. This orientation is south, 1.2 meters above the ground, white in color. These are WMO standards. So wherever you go, you can go to Zimbabwe or anywhere, you will find the orientation is similar. Obviously it differs with northern hemisphere and southern hemisphere. You are north and south, but the orientation is the same. So a typical Stevenson screen, this is what we're going to get inside. You remember the thermometers. Who still remember the dry bulb?
Yeah, dry and wet.
Dry bulb
And the wet bulb.
and the wet bulb. Which is which here? These two. Let me say it's left and right. Which one is the wet bulb?
The left one. Is it not the left one? The one with
The
that
left
glass?
one.
The one with
The
that
left one.
With that.
Yeah,
How do you call
sometimes
that?
I always tell school kids that you must always try to think outside the box. Ne? When you look at this thing, wet, what is wet? Now, it has to do with wetness, water somewhere. Then when I look at this, the glass here, maybe there's water there. Yeah, Ivana. So that you don't get too cram and all of those things. So this is your wet bulb, this is your dry bulb. This is your maximum, this is your minimum. So these ones, we keep them as backup nowadays. We don't use them.
Okay.
In fact, there was a communique from WMO, I think last year, that we must actually get rid of these thermometers, especially these ones that are using mercury, because there's danger associated with mercury, all of the scientific stuff. Understand? So, but we keep them for educational purposes as well, and for backup purposes as well. If something happens with our electronic
Load
stuff,
shedding.
yes, load shedding, electronic stuff. At least we can always come here and check and compare whatever. But normally we do a maximum. You remember the differences. This one is got the mercury, ne?
Yeah.
Maximum. Why? Because mercury it expands. This is your maximum. You remember mercury, when it's hot, the mercury expands. Ne? And this one is not using mercury. It's liquid type, eh? It's like a spirit, this bluish spirit inside, because it's moving. Eh? So this one, remember, it's dry bulb, actual temperature. So you remember the relative humidity. You use wet bulb and dry bulb to calculate the relative humidity using the formulas and all of those things. So in the nutshell, this is Stevenson scale. So now, like I've said, technology has taken over. So now there's a box here. We call it a junction box. That's where the technology comes in. There's another instrument here. This one, you can come closer with this beehive here. You see this white beehive. So you remember these 4 thermometers. This thing, it does the job of these 4 thermometers. but now it's one instrument. One instrument has taken over the job of all these 4 thermometers. So you don't need, there's no water here, you see, but he has taken over the wet bulb duties. Ne? There's no mercury, there's nothing. So we call it a temperature humidity sensor. So you see now this technology goes in here and then it goes to the office and it's electronic stuff now. It's computerized. So you look up there, we've got our temperature, our wind sensor. That's where you get your wind direction, wind speed and your wind gust. Yeah. So it's live, these instruments are live. So if you go to the office there, you look at the weather display system. So it will display all this information that comes from. Everything comes from this junction box, and then it goes through the office. Okay. What do you call an instrument that measures wind direction and wind speed? Anemometer. Anemometer. There's a guy called R.M. Young. He's the Chinese guy who actually invented or produced or whatever this instrument. That's why if you look at it, there is called at the back there, it's written Young. So some they call it R.M. Young sensor because it comes from China. Okay? So it was developed by a guy called R.M. Young. So others they call it R.M. Young sensor, but the scientific word is anemometer. Okay, so with this instrument you've got temperature and humidity, your minimum, your maximum. Then we've got now wind direction, we've got wind speed here, and then we've got wind gust. What is left? It's a rain gauge. Rain gauge. Then this is the rain gauge. Right up. I'm not going to waste too much here. Go and see the lightning there. These instruments are live, okay? That is not. I can open it. Right. You see, this is the funnel. You remember the funnels? The rain comes in here, and then it goes inside here. That's where the activity comes in now. Here you've got this, we call it a tipping bucket, this whole thing. So when it rains here, it just tips. I'm not sure I must tip it, and then I will tell them to delete it. Because if I tip it like this, they will think that the computer will think that it's raining because it will record. Remember, one tip is equal to 0.2. One tip 0.2, 0.2, 0.2 until 1 millimeter. 0.2, 0.2. So it's live. So as the harder it rains, the tick, 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 when you are sitting there at the computer, then suddenly within 10 minutes it's already 25 millimeters, 30 millimeters, you see, then you can say, no, there's too much rainfall. No, and we've got this instrument all over the place. Like if you go to Johannesburg, you see this famous Jacques K River in Alexander. We've got one as well there to monitor the floods there, so that the disaster management can issue out warnings when we send the information to them. Look, the floods are coming in that area because in the last 15 minutes already is 50 millimeters of rain. So it calls for floods. Then we send warnings to disaster management, then they can evacuate people there. So this thing, it uses a technology radar.
Yes.
This one, it's an old stuff. It doesn't have those things.
You mean the reed switch?
No. Automatic rain gauge like the one there in front there.
No, it doesn't have that. This because this one is joined to the junction box.
Yeah.
We use it as part of this setup. But in the event of what he's talking about, the Yexke River,
Yeah.
we will have another little device underneath it
Yeah.
where all the electronics is built into it.
Yes.
And that is for disaster management.
The one that we send is got some electronic stuff there, your modems and your SIM card, your normal SIM card. It uses the cell phone towers, something like that. Then it can call, it calls the office immediately. So Raidal is one of our engineers here. The guys that actually make sure that this stuff is working for us. Ne? So that's why I brought him here. He will explain the lightning detector there. So this is the rainfall. Ne? I don't want to waste too much time.
I just want to ask, why is this, why is
Irene.
the station here?
Uh,
this specific one. Why did you choose this location?
Raidal, can you tell
Okay.
them about the history of this place?
Okay, firstly, part of the history of the site is that this is what we call a WMO, World Meteorological Organization site. So they give us a grid per country, and according to that grid, you then position your equipment accordingly. So this is one of those very critical sites, especially for them. That's why almost everything is done here. You see I think Peter indicated to you guys the upper air is done here as well.
Yes.
So that upper air that is done there is done for all 5 the big airports here in Gauteng, for example, because they all need the upper air sending.
The
information.
balloon.
So
Upper air is
similarly
the balloon.
with the station here, the station is a WMO accredited station according to their criteria.
Yeah.
Does that answer you?
Yes.
Yeah. So while we're here, you remember the radar that we talked about, Orzana? Is that one? That big one? Yeah. That one is an improvement of this one.
Okay.
We started using this one, now we're using that.
That one.
But we also keep this one as a backup as well. But when you call us, want to know what's happening in Bronkhorst Strait now, we look at that one. Ne? So they were commissioned, I think, in 2014, no?
Yeah.
2014.
From about 2010 to 2014.
By the minister, who was the minister then? I don't remember, but it was around 240 million to commission these radars.
Yes, 10 of them around the country, and then there's 2 smaller ones.
Yes, the last one is this one. But this one is, there's no wiring here. Now you can see it's paper. We call it a sunshine recorder. This one. Outside the box, sunshine recorder. It means it's recording sunshine. Ne? So this paper here, it's a sunshine chart. So this is a sunshine recorder instrument. Then it's got a sunshine chart. So everything is live here. Ne? Don't want to mess up with this instrument. So if you look at it, it's got numbers. So the middle number is 12. You can get closer if you want. The middle number is 12. So these numbers, they represent time. Ne? And then if you go this side, and then it's 12, 11, 10, 9, 6 in the morning. Then you go this side, it's in the afternoon. So when the sun comes out, this side, it will burn this glass here, and then it goes through, it burns the chart here. Then I can tell what time did the sun come out here. Okay, it started to burn this chart around 6 o'clock. So it was burning this chart all the way. And there was no disturbance, there was no cloud, there was nothing. If there's disturbance there, maybe there's clouds, obviously it will obstruct the sun. Then it will not burn the chart. Then when I look at this chart, then I can tell between 12 and 13, the chart did not burn, meaning there was clouds somewhere there with the interpretation of this chart only. So you get a lot of information by just looking at this chart. So now you can even tell it's almost towards 4 now. 25 to 4. What time is it now? Yeah?
5 to
5 to 4. So now you see now it's going towards 4 now, because you see now it's 15. No, it's burning here now. Yeah.
Where do you look?
You must look where the concentrated light is of the sun.
Okay.
Yes.
Okay.
Yes.
I mean this this is the pattern.
Yes,
Burning
it
this one,
starts burning this side,
This
starts
side of it.
burning,
So it's there now. Yeah.
Yes. So when the sun goes down, it will start burning this side. So you can tell the sun went down roughly around 18, between 18 and 19 hours in the afternoon. Okay. Around 6 minutes.
So every day, how late do they?
So we change it every day after
morning.
the sunset.
After.
Yes.
So that it's
The
ready for
afternoon
tomorrow
guy
morning.
will come and change it. So let's quickly go to that last one, and then that's it for the day. Then we release the balloon. Ne?
We can even talk from here,
From
unless
there.
they really want to see the sensor.
Okay.
closer.
Okay, but yeah, because we are not going to open it.
No, we're not. We
Yeah,
don't need to open it up.
Yeah, that
I also
instrument
underst-
there, you see here, there's an instrument, that's a white instrument there. Yeah, I want right now to explain
Yeah.
to you what is it all about.
So what is that? It's basically a lightning detection sensor. How it functions is that we have what we call location accuracy and detection efficiency. Those are two parameters that tell you where exactly a lightning strike took place and what the intensity is. So what we do is we then the X, Y, and Z from mathematical principle, which we then use to determine exactly the location around the country or around the world that this lightning strike took place, and also the intensity of that strike. Because that strike will also tell how far the dissipation of radiation across the surface of the Earth. Sometimes you would find, for example, kids are playing on the school ground, but the lightning strike took place 5 kilometers away. But the kid here on the school ground collapsed on the electrical shock. That's the radiation of the charge over the surface of the Earth. And these things come from very low frequencies up to extreme high. So that's basically the principle behind it. So what we have in South Africa currently, we've got 24 plus 1 in Swaziland at this moment that cater for the entire South African country. To make sure that we have got a radius of 250 kilometer radius, so that we can have best locations again according to WMO and other guidance, that we know where to position these sensors. Of course, this is also very critical for your power generation, like Eskom. Eskom uses this because they need to be able to shut down, let's say they've got 2 feeds to a central point, they will shut down the one substation that is closest to the lightning strikes, so that the alternative site keeps the power going. Other than that, if the lightning strikes the site that is live, it costs the country quite a couple of millions, just for a simple transformer that might explode or site burning down. Okay. So it's very critical that for that purpose. But it does help to warn people beforehand, and then we use the radar and the LDM together to track the storm. So the radar we can use to track where our storms are going, as well as the lightning sensor then to be able to say what is the potential in that storm. So if there's a heavy storm, we already can warn, for example, Eskom or the agricultural department, etc., etc. We can warn them before and listen here, take your animals inside because there's a chance that your animals might get struck. Please remove them and put them inside the building. Or shut down your station, you can warm it up again at such a point in time. So sometimes it's not always, even with Eskom, it's not always load shedding. It's protecting you. Because also if that strike happens on the lines, it can even feed back into your house and all your equipment can be blown. Sometimes even around our houses, we haven't checked, most of us, but there's a thin copper strip that normally hits into the ground. That strip must be connected, otherwise if you touch your metal taps, you get a shock, electrical shock. That means your grounding of your house is not right. And that means that when a lightning strike does take place close to your house, it can destroy all your equipment in your house. Your TV, your hi-fi, your microwave, the works, and you don't want to lose that. So then you can't blame the insurance because you actually didn't maintain your house properly. Yeah. And remember, the insurance agency is one of our clients as well. so they
So you
will
can't
get
lie.
information from us to say, no, there was a lightning strike, yes, but at the same time they're going to come to your house and say, when last did you check your earthing of your house? If you can't confirm that with your COC electrical certificate, unfortunately you won't get paid out. So there's a whole lot of these things that works together, but benefits us in the long run.
So you go to claim, they come here. Here my TV was struck by lightning
Yeah.
on the 13th of February.